Good day. So today we will be learning about the complete gas law. Our objectives today are to apply the complete gas law to solve problems and to explain the gas law in terms of the kinetic theory. So let's get to some examples.
So let's write down what we know. V1, the original volume, is 9 liters. T1 is 300 Kelvin. And P1 is 1.5 atm. V2 is 3 liters. T2 is 600 Kelvin. And P2 is what we're looking for. So that's what we got to find. So let's start with this equation. P1 V1 over T1 is equal to P2 V2 divided by T2. So P1 is 1.5, V1 is 9, and T1 is 300. P2, we're looking for that. V2 is 3, and T2 is 600. So let's cross multiply. We're going to multiply 1.5 times 9 times 600. And you should get 8,100. Next, we're going to multiply P2 by 303. 300 times 3 is 900. So that's 900 times P2. Now let's divide both sides by 900. 8,100 divided by 900 is 9. And so you do get the same answer. P2 is 9 atm.
And now we'll take a look at each gas law and how they relate to the kinetic theory. We begin with Charles' law.
If you heat up a gas, it expands. The gas particles move faster, and they take up more space. Imagine a balloon that expands when gas particles bang against the sides. By expanding, that keeps the pressure constant. The faster the gas particles move, the more they will push on the sides of the balloon, expanding it. If, on the other hand, you cool the gas down, you put your balloon on ice, that slows the particles of gas down, so the balloon will contract.
And now Boyle's law.
If you exert pressure on a gas, you can compress it. Make it take up less space. Imagine a hard container that measures how many times gas particles bang against the sides. The more the gas particles bang against the sides, the higher the gas pressure on the container. If you make the container smaller, you compress the gas. The particles of gas will run into the sides more often per second, so that means higher pressure. If you keep the amount of gas particles constant, but you make the size of the container bigger, there will be fewer collisions per second with the sides. That registers as lower pressure.
And finally, the pressure law.
If you heat up a gas, the gas particles move faster. If the gas is in a solid container with fixed volume, this means that the faster the gas particles move, the more times per second they collide with the sides of the container. That registers as increased pressure. The converse is also true. If you cool down this container of gas, that means the gas particles are moving more slowly. So there will be fewer collisions with the sides of the container per second, which means lower pressure.